So we are live now. I'm not sure how to confirm if the page is updated too. Okay, Daniel says that the page is updated. Can somebody please confirm if you are hearing me? Okay, I need... Cool, let's start. I'm really sorry about that. I messed up. I misunderstood the question from the organizers, but now we are all set. My name is Leo Arias, and together with Federico Jimenez here, we are the QA team for Ubuntu Snappy. And what I want to show you today is more or less what we do daily. A quick tour of the stuff that we try, we test daily, the tests we write, and the things we explore. So hopefully it will seem interesting for some of you, and you would be wanting to help us. That would be really nice because we have a lot of things to do, and there are some interesting problems to solve. So let's get to it. Well, on the plenary, Mark already explained what's Snappy. I will just summarize it. Like, we have Ubuntu Core, that's bare bones Ubuntu, really secure, but also limited with a lot of constraints and read-only partitions that you can't modify. So we can do transactional updates and rollbacks, but also so we can trust that third-party applications won't break our system. So Snappy sits on top of that to sort of manage the system. It will take care of those updates and those rollbacks, and it will communicate with the store so you can easily install apps. And there are provisions for security and for services and a lot of stuff. There are many sessions during this week. So if you want to know more about Snappy, just look for those sessions and ask your questions, and I hope you will like it. This is a little unstructured session. I will be throwing at you some links, some commands. I will show you some code and things that we do. So please stop me if you have a question or you want to dig into something. I have prepared only like 30 minutes of stuff, so feel free to ask a question on IRC. Just make sure that you prepend your question with the word question, all in caps, and somebody will catch it and send it to me. Maybe Federico, you can monitor IRC for questions in case I miss them.
Okay.
And during this session, you will notice that there are some simple things like low-hanging fruits that people can jump on and start helping immediately. There are some more complex things, and it's lucky that we have Federico here. He will take care of the hard questions. You will see on the code base that when the problem is easy, I wrote the solution. When the problem is hard, it's Federico's solution.
No way.
Let's get to it. To get started, the first really thing that you would like to do is to give Snappy a try. And it's really cool that it's small and you can fire it up in a virtual machine. So I will show you a little how it looks when you do it on KVM. Let me share my screen. Okay. So I have here a directory where I keep my snappy downloads. I'll try to make it bigger. Okay, I hope you can see it, but anyway, I will be sending the links to IRC and the code to IRC. We have a daily image on the rolling edge channel, and that's where the new stuff comes. So Federico and I are constantly giving a try to this image. And as it's daily, we can do some nice things testing updates from previous versions. And in this directory, I try to keep as many images as I can to try some weird conditions that happen from old versions to the latest and stuff like that. So the first thing you would like to do is to get the image. And for that, there are two ways. We are publishing the stable image in an FTP server, like with normal Ubuntu images, but you can also generate an image gathering all the parts from the servers and building your own with this command, Ubuntu device flash. So I'm telling it here that I want to get Ubuntu core, the rolling release on the Edge channel. This is the latest things. The things that happened yesterday will be here. I want to enable developer mode, so that will allow me to SSH easily into the machine. Probably change some other things, but for now, I only care about SSH, so I can access it and test it. So let me give you this link that explains a little better where you will get Ubuntu device flash. It's pasted on IRC. It's at developer.ubuntu.com /n/snappy/start. There's a KVM section in there that does precisely what I'm doing here. Now let me paste the Ubuntu device flash command in case you want to do it instead. Sorry. So this will be really slow because I'm from Costa Rica and things are really slow here, especially internet. So I'm prepared. I already downloaded the image, and if you look at the directory that I have here, I always put the number of the image in the name so I can keep track of it. But also, it's important later when you make snapshots and you make updates. So the next command is to fire this into a KVM. Let me paste it too. It's on the page I linked before, but so you have it closer. Let me explain a little what's in here. I'm telling KVM that I want a machine with 512 memory, and that's just enough. Then I tell it to redirect some ports. This will be running on my same machine, of course. It's a virtual machine. And if I have on my real machine the port 80 occupied, then I won't be able to access the port 80 on the VM. So I'm telling it to redirect port 80 on the VM to port 8090 on the real machine. So if I do localhost :8090, I will be accessing a service in Snappy. So I want to redirect a couple of things here. This 80 and 8000 are for some services that we use to test. But the most important is this one. I need to redirect the port 22 on Snappy to port 8022 on my machine, so I can SSH into it. I will show it soon. And this is the path to the image. This snapshot is really important because we will be modifying the image, and during the day we have to do this like a lot of times, and if I don't make a snapshot, then I make an upgrade, or try a failed update and break the machine, then I will have to download it again. And as I told you, internet is slow here, so this snapshot is important. Once I run this, I get a small QEMU window that lets me connect to the machine. Here you will see it's booting, and when it's done, I will be in Ubuntu Core Snappy. You can see that because of the message you get on top. You can also run the snappy comments. Snappy list -b will tell us that we are on version 220 of Ubuntu Core, and that there's this snap specific to this machine, which is generic AMD 64. If you install this in a different platform like BeagleBone or something like that, you will get a different snap in here. And also you can see that this is a different word running apt-get. The command is not present, and we are telling you to use snappy instead. So the things that you used to do, like apt-get update, apt-get upgrade, apt-get install, you do them through the snappy command now. They are really similar, but the implementation is totally different, and your machine will be a lot more secure by doing these updates. I will show you a little more later. Okay, but I don't like this. I don't like this machine, this window, because it's too small, the KVM one. I prefer to connect through SSH to the machine. What it's telling me here is that the SSH key of that IP is not the same I had registered, because I used it before. So I just remove it from the known hosts and try again. It will tell me this is a new IP I haven't connected to before. Yes, I agree to connect. It asks me for the SSH key that it copied when I did Ubuntu Device Flash -- developer mode, but I don't want to use that. I can use the user IP for now because I haven't disabled it, so I can access with the Ubuntu user and the Ubuntu password, which is of course not secure. The first thing you would have to do is to update that. So now I'm again on the same machine. This is Snappy, as I told you, snappy list -b. You will notice that you are in a different environment. And this is the first step that we do to explore the system. This is what we do to manually test Snappy. Well, the first thing, we also test some boards, but it would be great if we had more hands just running commands in here, trying to see what breaks, trying to see what works, and exploring it. And you will find that it's really interesting. You will like it, and probably you will end up writing some snaps and doing your own development in here, because it's really cool. So let me show you a couple of things that we used to explore when we run sudo snappy install and the name of a package. It will go to the Ubuntu store and will download the snap by that name. In this case, it's Hello World, which is a sample snap that has a lot of interesting properties that we can use to test simple and not so simple things. It's really small, so it was really fast, and you will see it installed here. If I run again snappy list -b, you will see the Hello World package, the date and the version that it was installed, and the developer that made it. This is really important because you can have forks. You can install the Hello World by another developer. For example, I have one. So if you install sudo, well, we can search for it. Snappy search hello world. It will tell us that there are some forks, and I can see them with show all. So here's my hello world example. That's a copy of the hello world in the store, but with a little modification. I could install it also with sudo snappy install hello world. Hello. Well, I would have to uninstall the other, but let's not do that. Let's play with this one that's already installed and has the same functionalities. So the hello world has a couple of binaries, well, more than a couple. The simplest one is hello world.echo, and it just prints hello world to the terminal. So we use this to confirm that the store works, that snap install command brings a snap and installs it, and also that the binary is able to run even in this confined world. You will notice that this snap is not installed like any other devs are, that they take the root file system and can do anything in there, and they select some places to put their files, their binaries, like user share bin. In this case, the package is isolated, and by running this command, we confirm that the binaries work. But this is a simple binary. This is another a little more complex one that tries to do something it's not allowed. So hello world.evil, that's a binary to confirm that the isolation works. It's trying to create a file in /var/temp, and Snappy is not allowing it to run it. That's really cool. So you are safe, your system is safe, and you know that the third-party applications that you install can only play with their own data, not with something that's system-wide. Let's run another example from the same hello world. There's this binary called usehw, use hardware. And what this binary shows is that the snap, the application is isolated. It's trying to access a path for which it's not allowed, a hardware device. In this case, def kmessage. And Snappy is not allowing it, but for some snaps, we would like them to access this hardware, but we have to tell Snappy to allow them to do it explicitly. So with this command, snappy hw-assign, we can tell the name of the application that we want to allow and the path. So we are telling it here. Let me paste it again. Let me paste it on IRC so you can see it better. The application is now allowed to access the device. If we do it again, it will give us a different message. The binary tries to read it, actually reads some information from kmessage and tells us that it worked. So those are really simple things that you can do to test Snappy, test the store, test AppArmor, test the isolation. We have some more examples in there that you can explore. It's a good way to get started. Okay, remember that if you have any questions or would like me to dig a little deeper in something related to what I'm saying, just stop me and who will take care of that. If not, let's switch to the code. Let me give you the link to our source. Snappy is being developed in GitHub. So I pasted in there the GitHub URL. And this is a part of the system. As I told you, Snappy has different parts, and you saw there that there's a snap for Ubuntu Core. There's a snap for the platform. This project here is the one that takes care of installations, updates, rollbacks, some services. What we do daily is to combine these with some packages from the Ubuntu archive. The minimum number of packages that we can possibly use to get a useful system, a useful and complete system, and that's the image that's resulting. So the snappy binary that we ran and all those commands that we did are implemented here in this branch. So this is written in Go, and I suppose not everybody is an expert in Go. It's quite new, but it's really cool. So let me show you a little code and how we test it, how we do unit tests for that code. I want to show you about coverage and the reports we're getting. And then I will show you about the integration tests that we have for Snappy, which are written in Go too. So it's quite nice. Go is readable and it's simple. It's not Python. I like Python a lot more, but this is a lot faster than Python. So it gives us a lot better performance. So here you can see at the code that Chpaka wrote like a month ago to give Snappy an API, so you can access it from other programs. You could like control the updates, the installs using a nice REST API. So in Go, you define variables as in any language. This is a list of commands. And here you can see that we define the paths and the responses. I won't dig too deep in here, but it's pretty readable. If you access the API on the root path, you will get the version of the API. And if you can do some more difficult things, some more complex things, like getting the icons, listing the packages, getting the information from a single package, and you can also put a package, config or post a package. If you post a package, you will effectively install it. So the equivalent of sudo snappy install and the name of the package on the API would be to get to do a post on this path with the name of the package. So it's pretty cool. It's new and it's in progress. If you're interested in the code, you can help in there. But let's look at the tests, which is what I'm interested in. And this is using the internal Go testing framework plus a helper called Go Check. So it provides really nice things. And just with any testing framework, we define a suite, and there are methods for that suite. These are helper methods for the tests. But there's a setup, as with anything, a teardown. This is for the suite. There's a setup for the test. And let's find the actual tests. So this is how you define a test in Go. You put the word test in front, you make it a function of the suite structure, and you pass a reference to Go check that allows us to do some nice things. And there's a setup phase where you look for data to inject into your system, and then there's action commands in the end. What we have are assertions. And it's really nice. It's really readable. I won't dig too deep on the unit tests because this is the work of the developers in Chipaka. They are taking good care of that part. We are looking more at integration tests. So just to close this part, okay, let me paste the link on IRC in case you're following up to take a look at the code. But let me also paste a link to the coveralls report. So coveralls is a nice website that let us upload coverage reports. And we are using it for the unit tests in Snappy. So you can see in this report the lines that were hit by unit tests. If they are green, they are tested. If they are red, they are untested by this suite. In this case, we have, let's see, almost 60% of coverage on the api.go file. That's good, but can be improved. So if you're interested, if you know Go, if you want to dig into the Snappy internals, this is a great place to help. Just take a look at the functions that are not hit by unit test and write a unit test for them. Some are really simple. There are some cases where it's more complex. But you can get an idea looking at the code how to get started, and you can always talk to us if you want to help. We will give you a hand to get started. So coveralls is really pretty, really nice, and it's telling us that we're slowly improving our unit test coverage. But that's not all the kind of testing we do. That's not all the automated testing that we do. So let me paste another link to a different kind of test. This is a test in the integration suite. On the integration suite, what we want to do is to approach Snappy as a black box from the point of view of the consumers. So we won't go into the internals. We won't look at the structs, at the variables, at the return values. We will look at the things that Snappy is printing on the screen, or at the things that the API is returning us when we hit it. And in here, we also have like a huge variety of tests. Some are really simple, some are a little more complex. So I'm going to start with a simple one. If you want to get involved, this is a good place to help. In this case, it's the info suite. So what this suite does is to run Snappy info and check the output that it gets. So as I told you, you prepend the word test, and you relate the method with the suite, and you pass go check. That's the same as with unit tests, but we are running this at a different level. We're running this when Snappy is already installed and running in an Ubuntu core machine. So what this test does is to build a local snap. Go has some cool things to not take care of some details. So with the word defer, we tell it to run this function when the test has finished. So at the end, we want to remove the snap so it's clean again. We check that it built correctly, but that's not the part of the test that I care. We install it, and again, we make sure that it's removed at the end of the execution. This is where the real test starts. The rest was setup and cleanup and some things to keep it nice and clean for the other tests. So what I'm doing here is just running snappy info on the command line as I did manually. I'm simulating here that I'm a user entering commands, and I check that it returns the name of the snap I installed and the word sideload because I installed it not from the store. And that's the assertion I do. We have some more tests like that. This one is for installing a framework, not an app. You will learn about frameworks later in other sessions in the week. But there's also work here to do. We have some things in progress, and our idea is to split the tests that require internet from the tests that don't require internet, and that will make a really fast integration suite and one slower that we can run a couple of times a day. But the super fast suite will be able to run every 10 minutes or so. So there's work here to do. If you look at here, I'm not installing a local framework. I'm installing a framework from the store. So we have mixed slow and fast tests. We're cleaning this up. If you want to help, your hands will be really appreciated. So let's look at how this runs. Okay, and here. I'm not on the right machine. I was on the virtual host. Okay, on the GitHub page, you will find the README that tells us how to get the code. I already did that. I encourage you to get the code locally so you can exercise the tests. I have here the GitHub branch. It requires some setting up for Go. That's all explained on the README. So I just want here to run the info suite. I will paste the command on IRC. Okay, so what I'm telling here is to tell Go to run a file that has a main method. So what that main method does is to control the test suite. It provisions a snappy machine. It tells autopackage test to copy all the tests into that machine, and then uses autopackage tests to run the suite. In here, I don't want to provision a new machine. If you remember, I have a virtual machine running. The IP is localhost, and if you remember, I redirected port 22. So I will connect to the port 8022 to run only the info suite. And this will hopefully work. In here, I do have to copy the password. So this is my SSH key that was copied into the machine with developer mode. And you will see a lot of information going out there quickly. Let me see. Well, you will see that it passed. To passed, there's one test in that suite that we're skipping for now. Again, work to do if you want to help. But let me roll back a little so you can see what's going on. Like here. These are auto-package test messages, the things that you will get when it's provisioning the suite into the test. We do some setup to disable the auto-update features that will get into, that will affect the tests. But the real test starts here. Here's the setup of the test. Okay, so you will see here that we're running snappy build. This is the path to the snap, to the local snap that I mentioned. And this is the output path of that snap. So snappy build worked and generated the snap. Then we do snappy install of that snap. And finally, what we are checking is that it appears here. You will see the name is basic and the word sideload appears in there. So the test works as expected. Down here, you will see the other test that was about the framework, but let's not look at it for now. Let's try to run a little faster. I showed you the info suite. This is one of the most simple suites we have, but I want to show you one a little more complex. This is part of the snap of the daemon suite. I showed you the API daemon source code. Here we are testing that daemon as a black box. So just running posts and gets and puts to that. In this suite, we are telling, for example, to get the base URL of the suite and the path 1.0. So we check that it returns the information of the system from that suite. It says the channel, it says the flavor, it says the release, it returns status OK and 200. So all good. If snappy is running, snapd is running too, and we can access information about the system through the daemon. That test looks really simple, but this was something cool Federico did to make it easy. He has hidden all the Gore details in a base test that you will find on this path. And you will see here that we set up the daemon. We tell it to respond on localhost on a known port, and we define structs that the specific test have to fill to check things. You saw in there that we had a get, so we defined the response as we like it. This base test suite takes care of doing all the assertions and all that stuff for us. And we define the interactions we want to have with the daemon, like the payload we want to send it and how we want to wait for the response, and well, a lot of things. So with this base test suite, it's really simple to write a full coverage of all the API methods. Even if you saw on coveralls that the code had 60% coverage, with this black box integration test, we are covering a lot more than that from a different perspective. Okay, and we don't have a lot of time left, so I just want to show you one more suite that does one cool thing. It's not the URL here. Okay, so on this update suite, the cool thing that we are doing is faking updates. So you remember that one of the most important things of Snappy is that's transactional, and if something wrong happens, it will roll back automatically. So on this suite, in a lot of places, we fake updates. We tell the system that it's older than it really is. And do different things. Sometimes we force an error, so it rolls back. Sometimes we try the success scenario, and we do like loops, and we delete files, and we touch files and change them to be 0 bits, for example, and check that Snappy survives all of that. So that's possible because of some nice tricks that we do, but it's now all coded into the framework. You will see here that we have the test separated in 2 sections, before reboot and after reboot. So before reboot, what we do is to actually execute an update, check that that part went well. Then the framework will tell autopackage test to reboot the machine, and once it's finished, it will come at this place after reboot. And here we check that the version we had before the reboot is here. This is the one before the reboot, is smaller than the one we have after the reboot. And we have some other cool things, like we do a real update and then run the full suite with fake updates and fake rollbacks and things like that. Or we first run a real update, then a real rollback, and then run the full suite on the resulting machine. You can take a look at all of that in the source code of the integration tests. And you can join the channel Snappy on IRC, ask Elopio or F. Jimenez for some guidance. If you want to help, we will help you getting started. So I have a lot of things to show, but they will have to wait for following sessions, like how do we run this suite in a BeagleBone on our Raspberry Pi 2. We are starting to run it. We have a separate suite for Snapcraft. With Snapcraft, we generate the snap packages and we test that they are properly generated. We are also working on testing that they actually work on a Snappy system. So build the snap, copy it to a Snappy system, execute the binaries or services it has, and check what happens in there. Let me get back. Okay. And that's it. If you're interested, talk to us. We will be showing all these other things in Snappy clinics or after each Snappy release. I hope you join us. And if you have any questions, please let me know. We have like no time left, but we can reply on IRC. Okay, so I'll stop the Hangout and leave room for the next session. Thanks, everybody. Thanks, Federico. Sorry again for starting late. I messed it up, so sorry, Daniel and Nicholas. I will be seeing you soon. Bye.
Thank you. Bye.